Okay students, class 10. Today we will go through our special discussion of absolute refractive index and relative refractive index numerical problems. And especially we will try to understand different formulas related to refractive index. There are two types: absolute refractive index and relative refractive index. So that is very important. So what is the difference between absolute refractive index and relative refractive index? So that we will consider, and also we will go through again Snell's law of refraction, and we will see that different medium, how it behaves, and what are different formulas of refractive index. Refractive index is very big topic, and we have to consider in details this topic by knowing more and more formulas and by solving numerical problem also. So see on the board, we are going through some diagrams and some formula that is written on the board. Actually, when see, you can write, if you are listening, you can write some formula also, and one question also you mention. Question everyone write. Question is, if refractive index of glass is 1.5, again I am repeating, if refractive index or absolute refractive index, whenever we are talking about simply refractive index, so it is absolute refractive index. So the meaning absolute refractive index, that means refractive index of glass with comparison to vacuum. So question is you can write also with me. Question is, absolute refractive index of glass, absolute refractive index of glass is 1.5 or 3/2. We call it 3/2. The question is, if absolute refractive index of glass is 1.5, what information it gives? So this is question, and what will be the answer? Answer we are writing. Answer you can see I have written. The answer part you can understand here. Answer part says the information. Absolute refractive index formula is speed of light in vacuum, C. It is denoted by C. Now you can say, any one of you, do you know that what is speed of light in vacuum? We all know that the speed of light is maximum in vacuum, and it is 3 into 10 to power 8 meter per second. 3 into 10 to power 8 meter per second divided by speed of light in glass. Speed of light in glass. So if we are going through absolute refractive index mu g, it is said to be mu g. Okay, what we call mu a Greek letter. Mu is Greek letter and G for glass. Mu Greek letter used for refractive index. Sometimes n is also used, small n. So here we are writing formula 1.5, that is given, and speed of light in vacuum 3 into 10 to the power 8 meter per second, and Vg here, Vg we are bringing this side, Vg we are bringing this side, 1.5 this side, then you can see cutting 1.5 to 2 into 10 to the power 8 meter per second. Okay, so it is 2 into 10 to the power 8 meter per second. So the first information, if the question says, these are all board questions, in any examination this question comes, that absolute refractive index of glass is 1.5, what information we receive? We receive first information, that speed of light in glass is 2 into 10 to the power 8 meter per second. Second information, glass is more optical denser than vacuum. Second information. Okay, students? So, all of we are confirmed that refractive index gives many information. There are two types of refractive index. First, absolute refractive index. Second, relative refractive index. And both says the idea, gives the sense of idea of optical density of the particular medium in comparison to vacuum or in comparison to any other medium. Okay. Absolute refractive index of vacuum is 1. You know, absolute refractive index of vacuum is 1. Vacuum has got the minimum refractive index 1. So any other medium refractive index will be more than 1. Okay, more than 1. How much it is greater than 1? That will